Hello friends, welcome to lecture number 18 of Laplace transformation. Today we're going to discuss about inverse Laplace transformation by convolution theorem. Okay, and we're going to solve this question as well, which is taken from mathematical physics books by H.K. Das. Right, and before we start, please subscribe the channel, hit the thumbs up button, also share with your friends. Okay, and don't forget to hit the bell icon. Now if you want to follow me, then you can follow me on Insta. This is my Insta ID, Lakhyajit 123, right? And if you want to watch all the lectures, previous lectures, links are in the description box, and the playlist of this course gonna appear at the end of the video, at the end of the screen. Okay, the playlist containing all the lectures on this course, that's gonna be appearing at the end. Okay, now let's start. So inverse Laplace transformation by convolution. Now you see, if inverse Laplace transformation of capital F of S is suppose small f1 of t, right, and inverse Laplace transformation of capital F2 of S is suppose small f2 of t, right? So what we have taken, inverse Laplace transformation of this one is this, and inverse Laplace transformation of this is this. Then the inverse Laplace transformation of product of f1 capital F1s and capital F2s, capital F1 of S, capital F2 of S, that is given by integration from 0 to t, and then here we need to put this inverse Laplace transformation of it. This function is f1 of t, then replace the t by x. Okay, so that is what we're going to write here. Then into inverse Laplace transformation of f of t, f2 of S is f1, sorry, not f1, f2 t, right? Now replace this t by t minus x. Okay, then dx. So that is the convolution theorem. Okay, so now to understand it better, so let us take an example. Okay, so let me go to the next page, and I'm going to show how to solve a problem using this theorem. So now suppose we have a question: obtain the inverse Laplace transformation of this by convolution theorem. Okay, by convolution theorem. Okay, so this question is taken from H.K. Das mathematical physics books. Okay, so now let us solve this solution. So here this given function s square by s square plus a square whole square, it can be written this way: s by s square plus a square into s by s square plus a square. So let us take the first one as capital F1s and next one as capital F2s. So let me take that way. Okay, so we have taken this first one as capital F1 of S and the second one as capital F2 of S. Let me take that way as a product. Okay, so then inverse Laplace transformation of this product, right? Inverse Laplace transformation of this two product will be obtained by first let us obtain the inverse Laplace transformation of f1 of S, then f2 of S. So here you see both are same, both the functions are same in this case. So inverse Laplace transformation of both inverse Laplace transformation of capital F1s and the capital F2s will be same, right? Inverse Laplace transformation of capital F1s and inverse Laplace transformation of capital F2 of S, both will be same because here you see both F1 and F2 are same here, so we're gonna get the same result in this case. So inverse Laplace transformation of s by s square plus a square is given by cos at, right? We know that. Now you see, so small f1, so this is small f1 of t and small f2 of t, right? Both are same here. So what we have got this cos a t. Sorry, I made a mistake here. That's t should not be there. So cos a t. So this is f1, small f1 of t and small f2 of t. So we have got this. So now let us apply the convolution theorem. What is that? If the inverse Laplace transformation of capital F1 of s and is a small f1 of t, and inverse Laplace transformation of capital F2 of s is suppose f2 of t, small f2 of t, in that case the inverse Laplace transformation of product of capital F1s into capital F2 of s is given by integration from 0 to t small f1 of x into small f2 of t minus x dx, right? That's it. So we're gonna apply that. So here you see we're gonna when we write here f1s, so here f1 of t we have got cos at, right? Cos at now, here cos at. So f1 of x will be, this t should be replaced by x, okay? And when we also f2 of t is also cos at in this case. So here how to obtain f2 of t minus x? Just replace the t by t minus x, okay? So let's do this. So inverse Laplace transformation of this capital F1s into capital F2s is 0 to t, integration 0 to t, then small f1 of x. So we replaced t by x here, then cos a, then we need to write here f2 t minus x, right? So that's why replace the t by t minus x into dx. That's what we have got. So what we have used convolution theorem. So by convolution we have got this result, right? So that's why one more thing. So we know that 2 cos a cos b, this is trigonometric identity. We're going to use this cos a minus b plus cos a plus b, right? So let us take ax as a, so twice cos ax, twice cos ax into cos a t minus x. So considering ax and t minus x respectively a and b, okay? So we have taken this a and this one as b, right? Hope you have understood this. In that case, if we apply this identity, then we're gonna get this result. Right, so a minus b, this is a minus b, so b is here t minus a into t minus x. So we're gonna get at minus ax, right? When you're gonna put here minus at minus ax, then this minus will be plus on opening the bracket. So hope you have understood this, right? Similarly, we get this is ax plus a into t minus a into x. This minus ax plus ax gone, right? So let me use this result here. You see, so what will be the cos ax and cos a t minus x, as we have here cos ax into cos a into t minus x. So that's why what we're gonna get, cos ax into cos t minus x is equal to half of this part, right? So that is equal to this. So now let us use this result here. Okay, so let me go to the next slide. So what we have got this in the last step, right? So and this result and we have simplified this this part, and then after simplification what we have got this result. Let me go back to the previous slide. We have got this result, right? This is equal to this one. So now let us replace this part by this result. We're gonna have this result. Okay, after using the trigonometric identity we have got this result. So now let us integrate. So now let's integrate this. So what we have done here, so here you see this ax, it becomes twice ax and minus at. Then here this minus ax plus ax come, right? So we have got cos at. Okay, so now you see, if we integrate this, we're gonna get sine of 2ax minus at divided by coefficient of x, because we are integrating with respect to x, right? Similarly here you see, as we are integrating with respect to x, so that's why this cos at will be taken as a constant. It will be taken out of the integral, right? So we're gonna get this result. Coefficient of x is here twice a, and we are integrating it from 0 to t, then plus half, then cos at is taken out of the integral from 0 to t dx. Okay, now let's integrate this dx. So we're gonna get this result. So I have put the upper and lower limit here. So if you put t here instead of x, you're gonna get this result, and if you put 0 instead of x, then you're gonna get this result. 0 minus at, that is minus at, right, divided by coefficient of x, that is a. Then here we're gonna get cos at into integration of dx is x, and if you put upper and lower limit, you're gonna get this result, right? T minus 0. Okay, so now here this is the inverse Laplace transformation of this function, inverse Laplace transformation of this. So this is the product of f1s and capital F2 of s, right? If you see in the first slide here, you see, so this is the function, and we have expressed as product of these two, which are f1 of capital F1 of s and capital F2 of s. So that's why, so instead of capital F1 of s, F2 of s, we have written this. So hope you have understood. Now let's go to the next slide. So here you see, this is what we have got in the last step. Let me write it. Okay, so this is what we have got, right? So now if we simplify this, here you see, then we're gonna get this, right? So here we have minus, here we have minus sine theta is sine minus theta is minus sine theta. So sine minus 80, that's gonna be minus sine 80. So minus it's gonna be plus. So that's why we have got here plus, right? These are very simple simplification. Hope you understand this. So here you see, so t minus 0 is t, so I have written the t first. Yeah, okay. So this is the result. We're gonna have sine 80 plus sine 80, 2 sine 80, so 2 to cancel, That's what we're gonna have, which can be written this way, right? So this is the answer. So hope you have understood this, and in the next video we are going to solve more problems on the same topic, by the same theorem, by convolution. Okay, and I'm gonna show you I'm gonna solve 2 or 3 more problems from the HKDAS mathematical physics books. Okay, so hope you have understood this, and if you like my video, then please hit the thumbs up button, also share with your friends, and stay connected, and see you in the next video.